Hello guys, welcome to Learn Infinity. In this video, I will be discussing some important MCQs of the 5 subjects which are machine, network, power system, measurement and EMFT. As you know, some exams will be around the corner in few months. So this video will help you guys prepare for upcoming examinations like OMC, VIZAG Steel and ESC examinations, and also OPSC examinations. And if OPTCL and OHPC examinations will happen, this video will surely help you. So before starting, I want to tell you guys that you need to concentrate on the concepts that I will share here with you. It will be a long video, but it will be fruitful to you if you are willing. Okay, then let's start. We will cover here total 50 MCQs, 10 from each subjects, and this will give you quick revision of the subjects. So we will start with the machine. Here we will cover the transformer and DC machine part. So first question, the efficiency of a power transformer is around. These are the options: 50%, 60%, 80%, 90%, 95%. This is a very easy question. The solution is 95% because usually the efficiency of power transformer lies between 98% to 99.5%. 98% to 99.5%. Why? Transformer has such large efficiency because the main reason is transformer is a static device. It does not have any rotating parts. Hence the mechanical losses are absent, which increases the efficiency. So next question, if rated DC voltage is applied instead of AC to the primary of a transformer, then what will happen? These are the options: secondary of transformer will burn, primary of transformer will burn, secondary voltage will be high, there will be no secondary voltage. So let's see what is the answer. So here the answer will be primary of transformer will burn, because as we will apply DC to the primary of a transformer, due to low resistance and absence of opposing flux, heavy short circuit current will flow, which will eventually burn the apparatus. So the option will be primary of the transformer will burn. So let's see the next question. On no load phasor diagram of transformer, the core loss component of the current remains in phase with. No load phasor diagram, it is asking about the core loss component of the current. So let's see what will be the answer. The answer will be primary supply voltage, because see here the no load phasor diagram, I0 is the no load current, and I0 equal to, here I0 equal to IW plus I mu. These are the vector additions. So IW is nothing but the core loss component, and I mu is the magnetizing component. I mu is in the direction of phi and IW is in the direction of V1. So it is asking about the core loss component, that is IW. So answer will be primary supply voltage. This one here, V1 is the primary supply voltage. So let's see the next question. At which condition of the transformer the equivalent circuit will be as shown in the figure? So here it is shown that it is a series circuit. The options are like this. Let's see what is the answer. So the answer will be under short circuit condition, because we know that under short circuit condition we will get the series branch, and under open circuit condition we will get the parallel branch. This will get in open circuit and this in the short circuit test. So the answer will be, as in the question it is given that it is a series, so the answer will be under short circuit condition. Okay, so let's move on to the next question. The flux in the transformer core, the flux phi in the transformer core increases with load, decreases with load, remains constant irrespective of the load, none of the above. What will the answer? It will be remains constant with respect to the load, because the net flux is always at constant level in transformer. Hence transformer is always called a constant flux machine. As the flux is constant, the core loss is constant for all loads. So the answer will be C option. So let's move on to the next question. Here the question is, the real working part of a DC machine is. The real working part of a DC machine is. Options are commutator, field winding, armature winding, none of the above. Let's see what will be the answer. The answer is armature winding, because armature produces the power. Armature is responsible for the production of power in any machine, in any AC machine or DC machine. Armature is responsible for power production. So the real working part of a DC machine is armature winding. Here you can see these are the armature windings, and these are the field windings. Okay, let's see the next question. The yoke of a DC machine carries dash pole flux. Options are, whole of the pole flux means phi. If the pole flux is phi, it is saying phi. 1/2 means phi by 2, and 2 times means 2 phi. So what will the answer? It will be 1/2 the pole flux means phi by 2. So the yoke of a DC machine. So here you can see the yoke is this part. Yoke is nothing but this part. So it will carry 1/2 of the pole flux, because we know that from north pole to south pole there is flux. If this is north pole and this is south pole, there is the magnetic flux. If this is phi, the remaining this flux path will be completed inside the yoke, so that the magnetic circuit will be completed. So here if this is phi, outside will be phi. So only this part is the half of the total part, or this part is the half of the total part. So in the yoke, 1/2 of the pole flux will remain. So the answer will be the second option. Coming to the next question. In a lap winding, the number of brushes required is equal to dash. Number of poles, number of pairs of poles, commutator pitch, none of the above. What should be the answer? The answer will be number of poles, because in lap winding we know that number of parallel path equal to number of poles. In wave winding, number of parallel path equal to 2. So lap winding, number of brushes equal to number of parallel path. As number of brushes equal to number of parallel path, so number of brushes will be equal to number of poles. So let's see the next question. The core B in the figure 17.24 is the external characteristics of a dash generator: shunt, series, flat compound, under compound. This curve, B curve, is characteristic of which generator? Let's see what will be the answer. The answer will be flat compound. As you can see, the terminal voltage is the same as the rated voltage. For flat compound, the terminal voltage, this terminal voltage is same as the rated voltage. For over compound, terminal voltage Vt is greater than V rated, and for under compound, Vt is less than V rated. So it is asking about the B curve, so it should be flat compound. Let's see the next question. The curve A in the figure represents the external characteristics of dash generator. As you saw, B was flat compound. It is asking about the A. So what will the answer? Obviously overcompounded. As you saw earlier, this was the flat compound and this is the overcompound. So answer will be overcompound, the last option. So this is for the machines part. Next we will move to the network part. Here we will cover the basics, KCL, cable, equivalent, RLC, and we will cover two-port network. So let's see what are the questions. 11th question. The wave shape of the current flowing through an inductor is this. It is like a ramp. It is like a ramp signal or ramp waveform. The wave shape of the current flowing through an inductor L, it is given I. So it is asking about the wave shape of the voltage drop across the inductor. What will the voltage drop? I is given. What is V? In inductor we know that V is equal to L di by dt. So let's see what is the answer. D will be the answer because yes, as we know VL equal to L di by dt. So differentiation of I, this term differentiation of I should be the answer. So if the ramp is there, differentiation of ramp is what? Step. Differentiation of ramp is step. So from the options we can see this is the step. So this is the answer. Next question. In a pure inductive circuit, if the supply frequency is reduced to half, the current will, what will happen to the current? If the supply frequency phi is reduced to, or you can say, F is reduced to F by 2. F is reduced to F by 2. Then what will happen to the current? So the answer will be double, because in pure inductive circuit I equal to V by XL, where XL equal to omega L, where omega equal to 2 pi F. So you can say I is inversely proportional to omega and inversely proportional to F. So if F is half, current doubles. So the answer will be B. Next question. An active element in a circuit is one which receives energy, supplies energy, dissipates energy, both receives and supply energy. Let's see what is the answer. Answer will be supplies energy, because active elements which supplies energy in an electric circuit or generates, or you can say generates and deliver power, such as EMF source, battery, op-amp. These are active elements. And what is the definition of passive elements? Which does not generate power but instead dissipates or stores or releases it, such as R, L, C and transformer. Transformer is a passive element. So it is asking about what is active element. So the answer will be B, supplies voltage, supplies energy. It can be voltage source, it can be current source, it can be a battery, it can be a op-amp. Okay, next question. The value of temperature coefficient of resistance of a given conductor. Temperature coefficient alpha. So it is asking about alpha is different at different temperature. So it is saying alpha will vary with temperature. It's same at different given temperature. So it is saying alpha is same, means constant at different temperature. Increases at temperature is increased, remains always constant. So it is talking about alpha. Let's see what is the answer. Answer will be A, is different at different given temperatures. So let's see what is temperature coefficient. Temperature coefficient of resistance is the measure of change in electrical resistance change in electrical resistance of any substance per degree of temperature change per degree Celsius. This is nothing but alpha. So actually for any material, the value of this coefficient is maximum at 0 degrees Celsius. So alpha is maximum at 0 degrees Celsius. Alpha is maximum at 0 degrees Celsius. If this is 0 degrees Celsius. So the value of this coefficient of any material at T degrees Celsius is 80. Then its value can be determined by the following equation. 80, or you can say alpha T. Alpha T equal to 1 by T plus 1 by A naught or alpha naught. So here the important point is alpha varies with respect to temperature. Alpha value is different at different temperatures. So the option will be A. It is an important question. So you can remember alpha is not constant with respect to temperature. Alpha varies with respect to temperature. And alpha value is maximum at 0 degrees Celsius. Here it is written the value of this coefficient is maximum at 0 degree centigrade. So coming to the next question. The condition for Ohm's law is that, what is the condition? Let's see what is the answer. The answer is the temperature should remain constant. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it. So provided all physical conditions and temperature remains constant. These are the two important conditions which should remain constant for validity of Ohm's law. So the answer will be option A. So coming to the next question. If Z parameter for the network T as shown below are Z11 equal to 40, Z11 equal to 40, Z22 equal to 50, and here it is given Z12, Z21 equal to 30. Then what are the values of Z1, Z2 and Z3? Here Z1, Z2, Z3. These are the options. Let's see how to solve this. So as per the question, here it is T-type network. It is a T-type network, T network. So I know that for T network it is easy to calculate Z. If here it is given Z1, Z2 and Z3, then we write V1, V2 equal to Z11, Z12, Z21, Z22 into I1, I2. And we express Z11 as Z1 plus Z3 and Z12 as Z3, Z21 as Z3 and Z22 as Z2 plus Z3. So in the questions these values are given. We need to calculate the what is the original values of Z1, Z2 and Z3. So given Z11 equal to 40, so Z1 plus Z3 equal to 40, Z3 is equal to 30 and Z2 plus Z3 is equal to 50 as per the question. So by observing this we can say Z1 equal to 10, Z2 is equal to 20, Z3 is equal to 30. So here the important concept is if there is this T network, here a T network is given, here is Z1, it is Z2 and it is Z3, you can directly write the Z matrix. You can directly write the Z matrix as Z1 plus Z3, Z1 plus Z3, here Z3, here Z3 and here Z2 plus Z3. Let's see the next question. A two-port network is defined by the relation I1 equal to 5V1 plus 3V2. I2 is equal to 2V1 minus 7V2. So here I1 I2 equations are given. So it is asking about the Z12. Let's see how to solve this. We express the Z parameter as like this: V1 equal to Z11 I1 plus Z12 I2, V2 equal to Z21 I1 plus Z22 I2. It is asking about the Z12 term. So how to find the Z12 term? Z12 will be V1 by I2 when I1 equal to 0. When I1 equal to 0, this term will vanish. So Z12 equal to V1 by I2. So put here I1 equal to 0. By putting I1 equal to 0, we can find 0 equal to 5V1 plus 3V2. So V2 equal to minus 5 by 3 V1. Again put this value of V1 in the second equation, in this equation. If we put this value of V2, if we put this value of V2 here in this equation, we'll get I2 equal to 41 by 3 V1. I2 equal to 41 by 3 V1. So we need V1 by I2. V1 by I2 equal to 3 by 41. So this is the answer. C will be the answer. Next question. Which one of the following gives the correct short circuit parameter matrix Y for the network shown below? These are the admittances given in mho. Okay, so what is the, it is asking about the Y parameter matrix. As you can see, it is looking like a pi network. So let's see what is the answer. Answer will be A, because for pi network, if admittances are given like this, y1, y2, y3, we can find Y parameter by Y equal to y1 plus y3 minus y2 minus y2, y2 plus y3. Here you should remember we have to put this minus sign. This is important. Minus sign is important. So here the admittance values are given. So simply we can put these values 0.5 plus 0.2, 0.7 minus 0.5 and minus 0.5 and here 0.8. So the option will be A. Here the concept is for pi network. For pi network, finding out the Y matrix is easier. We can find out by this formula. So let's see the next question. ABCD represent the transmission parameter of a two-port network when is the network reciprocal. So it is asking what is the condition for the reciprocity. So let's see what is the answer. The answer will be B, AD minus BC equal to 1. For ABCD parameters, what is the condition of reciprocity? AD minus BC equal to 1. AD minus BC equal to 1. For Z parameters, reciprocity condition is Z12 equal to Z21. Here is Z12, here is Z11, here is Z21 and Z22. So what is the condition of reciprocity? Z12 equal to Z21. Similarly, for Y parameters, reciprocity condition is Y12 equal to Y21. For symmetry, what is the condition? A equal to D. This element equal to this element. This is the condition for symmetry. Similarly, for Z parameter, symmetry condition is Z11 equal to Z22, and for Y parameter symmetry condition is Y11 equal to Y22. So these are the type of questions which are frequently asked in the examinations. So you should remember this. This is very important. So the here answer will be AD minus BC equal to 1, the B option. So 20th question, here it is given for the T notar. So you know that for T notar finding Z is easier by the formula. So here it is asking about the Z11. We need to apply the formula. What is Z11? Sorry, what is Z11? Z11 equal to nothing but Z1 plus Z3. I mean this plus this. Let's see what is the solution. Yes, Z11 equal to Z1 plus Z3. This element plus this element. So J40 minus J160. 40 minus 160 minus 120. So minus J120. So C will be the answer. So that's for the network part. Moving on to the next part, we will see power system. In power system, we will see generating power stations and transmission line parameters, corona and sag also. 5 questions from here, 5 questions from here. Let's see what are the questions. So it is saying what is the correct expression for the electrical power developed by a hydroelectric plant in kilowatt. This is a IS question. So let's see what is the answer. So P developed equal to 0.736 by 75 QHWN, where Q is the discharge which is expressed in meter cube per second, H is the head, this is the head of the water, and N is the efficiency. So it is matching to the option A. Option A is the answer. Coming to the next question, the function of source tank is to dash. What is the function of source tank? Let's see what is the answer. The answer will be relieve water hammer pressure in the penstock pipe. Source tanks are usually provided in high or medium head power plants. Source tank is a small reservoir or tank which is open at the top. So here you can see between dam and between the reservoir and the power station. In between there is penstock. Here it is the penstock, and in between these two, this is the source tank. Source tank will be open at the top, and it is fitted between the reservoir and the powerhouse. This is the reservoir and this is the powerhouse. In between there is source tank. The water level in the source tank rises or falls to reduce the pressure swings in the penstock. So to avoid the pressure swings in the penstock, the source tank is used. So answer will be B. Let's see what is the next question. For a high head and low discharge water turbine used each. So for it is asking about the high head. Which turbine is used? Pelton, Kaplan, Francis, propeller. Which one is used? Let's see what is the answer. For high head, the answer will be Pelton wheel. As you can see in the figure, this is the type of the type of turbine which is called the Pelton, and this is called the Francis, and this is the Kaplan. Pelton, which is used in high heads, Francis is used in medium heads, and Kaplan is used in low heads. Pelton has always tangential flow of water. Here water will strike the Pelton turbine tangentially. For Francis, both radial and axial flow of water is there. So this is radial and this is axial. So both axial and radial flow of water. But for Kaplan only axial flow of water is there. This is Pelton, this is Francis, this is Kaplan. So for it is asking about the high head, so it will be Pelton. Answer is A. So coming to the next question, on which one of the following cycles does a modern steam power plant work? So it is asking about on which cycle the steam power plant is based on. Answer will be the Rankine cycle. The Rankine cycle is a model used to predict the performance of steam turbines. Coming to the next question, steam is superheated in order to improve the Rankine cycle efficiency, reduce initial condensation losses, avoid too high temperature in the last stage of the turbine, or all of the above. The answer is all of the above. As you can see in the figure, this one is the boiler, and these tubes are superheaters. These tubes are superheaters, and this is the turbine. So superheaters are used to improve the Rankine efficiency, reduce the initial condensation losses, avoid high temperature in the last stage of turbine. So all of the above are correct. So option D is the answer. Coming to the next question, question number 26. The surge impedance of a three-phase 400 kV transmission line is 400 ohm. What is the surge impedance? Loading. Loading means it is power. What is the power it is asking? Let's see. The answer will be A option, because the characteristics impedance ZC, we define the characteristics impedance is root over of Z by Y, where Z is the impedance per unit length of the transmission line and Y is the admittance per unit length. So if we consider for the lossless condition where R equal to 0 and G equal to 0, then ZC will turn into Zn, and it will be root over of L by C, which is called the surge impedance. So surge impedance is Z equal to root over of L by C. This is the surge impedance. If it is asked about what is surge impedance loading, means it will be V square by Z, V square by surge impedance. So as you can see, V is given 400 kV and surge impedance is given 400 ohm. So surge impedance loading equal to 400 into 400 divided by 400. Answer will be 400 megawatt. So A option is the right option. Coming to the next question, the good effect of corona on overhead line is, what is the good effect of corona on overhead line? Let's see what will be the answer. The answer will be reduce the stiffness of surge fronts. As you can see in this figure, the transmission lines are showing the corona effects. A purple glow is appearing on the lines. So the phenomenon of ionization of surrounding air around the conductor, due to which luminous glow with hissing noise is known as the corona effect. So if this is the conductor cross section, this much is the conductor cross section, due to corona, the nearby air is ionized. So the incoming wave surge, it will block those incoming wave surge. So answer will be reduce the stiffness of surge fronts. This is the good effect of the corona on overhead lines. Coming to the next question. When is the Ferranti effect on long overhead lines experienced? Ferranti effect. It is asking about the Ferranti effect. So what will be the answer? The answer is the line is lightly loaded. A option. The effect in which the voltage at receiving end of the transmission line is more than the sending end voltage is known as Ferranti effect. Sending end voltage, receiving end voltage is less than the sending end voltage. Such type of effect mainly occurs because of the light load condition. The effect in which the voltage at the receiving end of the transmission line is more than the sending end voltage. The voltage at the receiving end of the transmission line is more than the sending end voltage. So if Vs is the sending end and Vr is the receiving end, so Vr is greater than Vs. This is the Ferranti effect. So the Ferranti effect occurs in the lightly loaded condition. So option will be A. If a medium transmission line is represented by nominal T, then the value of P of ABCD constant is. What will the answer? Let's see. For medium transmission line for nominal T, we represent ABCD parameter by this matrix. For nominal pi, we represent by this matrix. We can see these elements A and D. Here also A and D are equal, which are 1 plus yz by 2, but the B and C elements are varying. For nominal T, the B is z into 1 plus yz by 4. It has been asked in the question that what is the value of B, so it will be the answer. B is the answer. Sorry, B is not the answer. C is the answer because it is asking the value of B in nominal T. In nominal T, B is z into 1 plus yz by 4. So this is not the answer. This is the answer. Coming to the next question, the characteristics impedance of the transmission line depends upon. The characteristics impedance of the transmission line depends upon. What is the answer? The geometric configuration of the conductor. Because the characteristics impedance ZC is given as root over Z by Y, where Z are impedance per unit length and Y is admittance per unit length. So it is depending upon the geometric configuration of the conductor. So coming to the next subject, electrical measurement, we will see measurement of resistance and some questions on galvanometer, voltmeter and ammeters. We will here discuss 5 questions. Here we will discuss 5 questions. So 31st question, a standard resistance is made bipolar type to eliminate what? The options are here: capacitance, temperature effect, inductive effect, skin effect. So what will the answer? The answer will be inductive effect. So it is a typical bipolar winding. It is used to eliminate the inductive effect. Then coming to the next question, what is the answer? What is the question? Which one of the following is measured by the loss of charge method? The method is loss of charge. Which one of the following is measured by the loss of charge method? Let's see what will the answer. The answer will be high resistance, because you can see The measurement of high resistance. What are the methods? Loss of charge, Megger, direct deflection method, and mega amperage method. So it is saying loss of charge. So it will be high resistance. Answer will be B. Next question. Low resistance from few ohms down to 1 micro ohm is measured using which one of the following instruments? So it is mainly asking about the low resistance, how to measure the low resistance. Low resistance is measured with a voltmeter and ammeter. Other methods of measurement of low resistance are Kelvin double bridge method and potentiometer method. So the answer will be D option. Next question. The precision resistors are. What will the precision resistors? The precision resistors are nothing but the wire wound resistors. You can see the picture of precision resistor. A precision resistor is a resistor that has the very low tolerance value, so it is very precise, close to the nominal value. So the precision resistors are wire wound resistors. So answer will be B option. Next question. Which one of the following methods is used for the measurement of high resistance? These are the options. So it is just asking about the high resistance. As you saw earlier, these are the methods of measurement of high resistance. So the answer will be loss of charge method. Substitution method is used for the measurement of medium resistance, but loss of charge method is used for measurement of high resistance. So the answer will be C option. Coming to the next question, it is asking a moving coil galvanometer is made into a DC emitter by connecting what? So a moving coil galvanometer is made into a DC emitter by connecting. So the answer will be A low resistance across the meter. Here you can see the galvanometer, a low resistance is connected across the galvanometer and it is the ammeter. So you can convert it into the ammeter by connecting a low resistance across the meter. The answer will be A. Next question. One of the control springs of the permanent magnet moving coil ammeter PMMC permanent magnet moving coil ammeter is broken. One of the spring is broken. If connected in a circuit, the meter would read. Answer is 0, because here you can see these are the springs, right? So actually the springs carry the working current in PMC instrument. So if one spring will break, so the current path will be discontinuous, the current will be 0, so the meter will read 0. So the answer will be A. Next question. The deflecting torque of a moving iron instrument is. These are the options. What is the formula for deflecting torque of a moving iron instrument, MI type instrument? Let's see what is the answer. The answer will be B option. Here you can see this is a typical MI instrument where this is the moving iron and here the air friction damping is used. So the deflecting torque is 1 by 2 I square TL by d theta. Next question. The scale of a dynamometer type instrument marked in terms of RMS value would be. So it is asking about the scale. What would be the nature of the scale? Uniform, non-uniform, crowded near full scale, non-uniform crowded at the beginning, non-uniform crowded around the mid scale. So let's see what is the answer. The answer will be C option. Non-uniform crowded at the beginning. You can see in the picture. So it is a typical dynamometer type instrument. You can see 0 to 10, 0 to 10, see how much difference is there, and 10 to 20, how much difference is there. So 0 to 10 this much difference, and 10 to 20 this much difference. So you can clearly see that crowded at the beginning of the scale. So you can say C is the answer. Next question, 40th question. When a current IT equal to 5 plus 10 cos 314t is measured by an electrodynamic ammeter, the meter will read how much? We know that we have to calculate the RMS value of this current. So RMS value will be 5 square plus 10 square by 2, which is 25 plus 50, root over will be root of 75. So this is the B option. It is options here. The options are given in the expressions. So B will be the correct expression. So we'll move to the next part. EMFT will see. Here we will see electrostatics. Here we will discuss 5 questions. And for capacitance, here we will discuss 5 questions. So let's see what are the questions. 41st question. It is saying the relation between electric field intensity or electric intensity E and voltage applied V and the distance between distance T. E, V, T. What is the relation? Let's see what is the answer. Answer will be A. E equal to V by D, because as you know V equal to E dot dl, or you can say E into D equal to V. So E equal to V by D. So A option is right. Next question. Ohm's law in point form in the field theory can be expressed as. So it is asking about the Ohm's law in point form. So the answer will be C option. Point form of Ohm's law is J equal to sigma I, or J equal to current density. So the answer is C. Let's see the next question. It is saying the vector statement of Gauss law is. So what is the expression of Gauss law? Let's see. What is Gauss law? Gauss law is total electric flux crossing any closed surface is equal to the total charge enclosed by that closed surface. Enclosed electric flux crossing any closed surface is equal to charge enclosed by that closed surface. So if you will express in equation, d dot ds surface integral equal to volume integral rho by dv. So it is relating surface integral to volume integral. From options we can see T is the correct option. It is surface integral and it is volume integral. It is volume surface, not correct. Volume surface not correct. It is saying rho square, so it is not correct. So finally it will be correct. D option is correct. Next question. The electric field lines and equipotential lines are parallel, are on and on the same, cut each other orthogonally, can be inclined to at any angle. Let's see what is the answer. Cut each other orthogonally. This is the right answer. Because you can see for a point charge, the equipotential surfaces are like the spheres, spherical surfaces, but the electric field are radially outwards. So it is here forming 90° to the surface, equipotential surface. So you can say electric field lines and equipotential lines are orthogonal to each other or cut each other orthogonally. So C will be the answer. Next question. If a positive charge body is placed inside a spherical hollow conductor what will be the polarity of the charge inside and outside the hollow conductor? So what is the answer? Answer will be B. So it is saying a positive charge is placed inside a hollow conductor. So positive charge, as positive charge is placed here, it will induce negative charge here, and subsequently the negative charges will induce the positive charges outside. Positive charge will induce negative charge and negative charge will induce positive charge. So the answer will be inside negative, outside positive. B option is correct. Next question, two capacitors of capacitance 3 microfarad and 6 microfarad in series will have a total capacitance. Two capacitor 3 microfarad and 6 microfarad. 3 and 6 in series. So as you know, what is the answer? It will be 2, because 3 into 6 by 3 plus 6 equal to 9. 18 divided by 9 equal to 2. So 2 will be the answer. Next question, the capacitance of a parallel plate capacitor does not depend upon. What will the answer? These are the options. As you know, parallel plate capacitor capacitance equal to C is equal to epsilon R A by T. It is area, it is distance or separation, it is medium, remaining is metal. So answer will be metal. Answer will be metal of plates. This is the answer. So let's see the next question. A parallel plate air capacitor has a capacitance C. If air between the plates is exhausted completely, the new capacitance would become. So it is saying there is a parallel plate capacitor and initially it was air filled, then after it is completely vacuum. So it is saying what will the effect on C. Let's see, epsilon R value of air is 1.006. This was the initial value, and epsilon R value of free space is equal to 1. So epsilon R is reduced. We can see C is proportional to epsilon R. So as epsilon R is reduced, C will be slightly reduced. So answer will be slightly less than C. Coming to the next question, two spherical conductors A and B of radii A and B are placed concentrically in air. So it is asking about the equivalent capacitance of the system. So here radius is small a, here radius is small b. Then what is the capacitance of the system? Let's see what is the answer. The answer will be 4 pi epsilon AB by B minus A. This is standard formula also. Capacitance of a spherical capacitor. Capacitance of a spherical capacitor is 4 pi epsilon divided by 1 by A minus 1 by B. If you simplify 4 pi epsilon into, here AB will go to numerator by B minus A. So the second option will be is right. So this is a formula also, or a standard result also. The capacitance of a spherical capacitor CAB equal to 4 pi epsilon divided by 1 by A minus 1 by B. Next and the last question, 50th question, the capacitance of a coaxial cable between rho is equal to A. Coaxial cable means like this, cylindrical cable. This is the coaxial cable, and rho is here 1, and for larger cylinder rho is equal to B. So it is asking about the capacitance. Let's see what is the answer. The capacitance will be 2 pi epsilon H ln B by. This is also a standard formula. coaxial cable. What is the capacitance of a coaxial cable? Means 2 pi epsilon h divided by ln b by a. So what topics did we cover today? From each topic we discussed 10 questions, total 50 questions. And from machine part we discussed transformer and DC machine. From network we covered some basic concepts, two-port and basic concepts, two-port network also. In power system we saw generating plant, line parameters and corona. In measurement we saw measurement of R, voltmeter, ammeter. In EMT we saw electrostatics and capacitances. So that's for today. Thank you for your patience. See you in next video.